Hello students, in today's program we are going to see some programs related with multi-digit number. We will separate digits from the multi-digit number and work on it. So for that, let's see first one example. Write a program to read a number, multi-digit number, and find sum of digits using sub procedure. What the question is asking is, if your input number is 453, then it should find the sum of 4 plus 5 plus 3. So it should give the answer 9 and 3 makes 12. So it should work in this way. For that, what we need to do, so let's first see the logic. If we are given a number n equals to 4, 5, 3, to separate the digits here, we cannot use a mid-string function, so we use mathematical logic. Mathematical logic for this is, for any number, when we divide by 10, the last digit comes as the remainder always, as it is decimal number. So here 10 5s are 50, and we get the remainder 3. So in this way, when we divide a given number, the last digits always comes as a remainder when we divide by 10. Okay, so what we can do is, when we have a number here, so when n is divided by 10 and the remainder is of 10, let's say the remainder is d, as it separates out the last digit. Here in this case it separates 3, yes, and whatever the digit is separated out, we need to sum it up in a variable s equals to s plus d. On doing this, the last digit that we had just separated out, this 3, will be summed up in variable s. And now the work with the last digit is done. Now for the next digit, how to work? Here the last digit is separated out, and for this 5, we cannot divide by 100. If we divide by 100 for this number, 53 will be the remainder, or the separated 53 will be separated out as the remainder. So this is not good. This is not the thing that we need. So what we need to do is, if we can change the value of n to 45, then from here 5 is last digit, and that can be separated out by the same method, like 10 4s are 40, and the remainder comes here. That means we need to change value of n to just the 2 digit. That means we should remove the last digit. Now for this, what we can do is, if that number is divided by 10 and the quotient is seen there, then the last 3 will be removed out here in this way. That is why when we need to do such work, if we do the integer division, that means this is integer portion only when we do the division, then as required we get the number. So for that, what we can do is, the number is when divided by 10 and integer only is used. Only we are doing this as integer division, and this result is if kept in n. So n will change its value like this here in case of this number, when the initial number actually in the previous step, this step, only a copy of last digit is separated out. The number n has not changed its value. But this time, the quotient n backslash 10 means it will give 45 without decimal. And that will now be placed in n. In this way, when we do the work, the value of n will be changed like this. And when we do the work repeatedly again and again, the next digit, that means at first last digit was separated out and summed up here, and on looping next time, second last digit will be summed up, and in the same way third last, and it goes in that way. So how many times we need to repeat that thing till the value of n changing each time or removing each time one digit. If I will next time get 4 and next time will get 0. That means until the value of n reaches to 0, we should keep repeating this. That's why how we write the loop is while n is not equals to 0, or even we can write n is greater than 0. So let's once see its Dryden table. How does it work? Let's see here. Here we have n, next d, next s. Okay, so let's consider that n is given as 453, and now d equals to n more 10. So when any number is divided by 10, last digits come as remainder we had just seen. So I'm directly writing here 3. And then the separated d is summed up here in s. Initially s has nothing, that is it has 0. So 0 plus d means 0 plus 3 will make 3 and will be placed in s. That means this s will get the value 3 now. And then n equals to n backslash 10. By this integer division, we just have seen that it will remove the last digit from the number and will be placed in that same number. That means last digit 3 will be removed out. So value of n will be changed in this way. How the mathematics does its work, we just had seen there. Okay, and then it'll say wind, and it'll go for looping. It'll say check there, n is not equals to 0. It's true, it's still 45. That means the loop will run again. On running the loop for this time, n more 10, n is 45, more 10 gives last digit as the remainder, and that will be placed in d. So d will get the value 5. After this line, it comes here in this statement. Here s equals to s plus d means s has the new value of d is 5, s has 3, and 3 plus 5 makes 8. That will be placed in s. So s will get this value 8. It goes to this next line and gives the remainder n equals to n backslash 10 means integer division makes a value of n to 4 only. And on running the loop again, n is not equals to 0. Still it is 4. That means loop will run this time again, and this time d equals to n more 10. When this 4 is divided by 10, actually what happens, let's see. When 4 is divided by 10, 10 cannot divide this, but it can be divided 0 time. So it goes like this. So remainder will be 4. And that remainder 4 will be placed in d. So d will have value 4. And then s equals to s plus d. S is 8 and d is 4 now. So 8 plus 4 makes 12. And then n equals to n by 10, integer division. when that 4 n value of n is 4 and it's divided by 10 and integer is only of 10, then that integer we have seen here is 0. So the 0 will be placed in n. That means 0 will be placed here, and when we'll take here to while n is not equal to 0 but it has become 0, so condition is over, so no further looping will be done. So as here we have s is calculated, this s is the answer, sum of digits. Now if we do this using sub procedure, then how do we do? Let's see. Declare sub to give the name as it is going to find sum of digit. Then find sum of digit. Let's give the name sum of digit, SOD, for an input number. Okay, CLS input enter a number or multi-digit number, whatever you want, you can write. So I'm using variable num, and for subprogram we use call statement. Call name is SOD and the value for which we need to work is in num. So main program ends over here, and for its definition sub SOD equals n, and the block will be same. So during printing, let's give message also sum of digits in given number, like this, and in sub. Okay, then let's check this one, does it work or not? Okay, so 453, let's check for 453 the sum of digits in given number is 12. Yes, it's correct. And let's see once again for another example, 2 3 4. If 234 is a number, then it should give 2 plus 3 is 5, and plus 4 9 should be given. Yes, it gave the same number as we expected. Now work for you is print number of digits in an integer number. And here how do we do this? Actually in previous program we found the sum. Now you need to count the number of digits. Actually for counting number of digits, what we need to do is how many times this loop runs will need to be counted out, because the loop runs for each digit. That is why in place of summing up this, you just can keep one counter here, and as summing is done here, the d sum in place of this sum statement, just a counter, loop counter or iteration counter can be kept here. There will be no need of d in the statement, so you even can remove this. So from this logic, please do this number. Okay, so for next one, sum of odd digits. If we need to do another question, printing sum of odd digits. For finding sum of odd digits, what we need to do is, the program is already here for sum of digit. Now here when the question says sum of odd digits, here you just need to sum the sum of this d if this d is odd. To check that, we use d mod 2 equals 2 1, this means the D is if odd, then only do this. Otherwise, that means if D is even, the statement will not get executed and work will not be done. So you can write here sum of odd digits. So just by making this much modification, it does its work. Let's see. If our input number is 12,345, here odd numbers are 1 plus 3 plus 5 means 1 plus 3 makes 4 plus 5 makes 9. So sum of odd digit is given as 9. Okay, so now let's see for reverse of number. Okay, now you might have seen that how it works, and you found the reverse of input number. Now we still have another question here. Write a program to check a number and whether it is palindrome or not. So palindrome means the thing or the number or any word when it is reversed, if it gives the same original number, then that is called palindrome. So what we need to do is we need to find the reverse of a number, and we need to check whether the original number and reverse is same. Original number is n, because here inside this subprogram the num is received by n, so we need to check the original number as n. N is equals to the reverse we had calculated here is r. Then we need to say print palindrome, else print not palindrome. But here what we need to take care is this number n, original number n, is changed in this loop. That is why this n or the original value of n is to be preserved somewhere here in m. Now the m equals to n makes the value of n available in m. That means the value of n is assigned to m as well. That means whenever this loop changes the value of n and finally make it 0, we had seen in Dryden table, the original value is not remain here in n. Now as it is preserved here in m, we can check with m. So now let's run and check this. So let's keep one palindrome number. 1 2 3 2 1 is a palindrome number. It should give, it is palindrome. Yes, it gave palindrome. And let's see for number that is not palindrome. It is not palindrome, so it's giving not palindrome. Okay, in this way we can check for the number whether it is palindrome or not also. So class, for today's class this much. Thank you very much.